وحج زمال روا وحج زمال روا كمل كاف السجار حولنا تقليلو تفقيسو معقر
Hello, how are you? Those of you all of the family of this channel. My name is MaEd and I'm a mathematics teacher and tutor. As you know, we have seen last week the subtopic of this chapter, which says limits. Under this one, we have seen formal and informal definition of limits, one-sided of limits, infinite limits, limit at infinity, and at the final we have seen the different examples of special limits. And today we are going to see again the second subtopic, which says continuity of a function. Under this one we have two subtitles again: continuity of function at a point and continuity of a function at interval or on the interval one. So we'll see one by one. So a function f of x is said to be continuous at a point a, or at a point, or at any number a, if it satisfies the following three conditions. If it is defined at a point. Second, if the limit of f(x) as x approaches a is given with the functional value f of a. Third one, if the function has or approaches to f of a and it is exists. A function is said to be exist, which means that the left and right limit are the same. At that time, we say the limit of the function at a or x approaches a is exists. So a function is continuous at a number a. At that time we say continuous if it satisfies the three conditions. First one, it should be defined. It should be defined in a sense, if evaluating the function at the number a, it has not to be the value any number over 0, over 0 over 0, or infinity over infinity and extra. These numbers are called in mathematics indeterminate value. If you evaluate the value directly, if you get such values, at that time we would say undefined. So a function is said to be defined at a or at any number a. It should be different from these values. 1. If this criteria happens, then the second condition is no matter, which is directly the limit maybe as x approaches to a, the function it is equivalent with the functional value, or directly will be substituted at a function. If that one happens, again the function is also, it has its limit exists, which means that the left and right limits are exist again, or if they are equivalent. Okay, this is something which explains for the undefined instance. This picture shows a cat and a rat, where the rat is over the head of the cat. This never happened over the world. Why? Because they cannot exist. Which means that the rats, so as well as It is never to be overhead of the cat, the rat never to be overhead of the cat. Why? Because it will be consumed for the sake of the food. At that time, the life of the rat is discontinuous or not continuous, or it cannot be alive. So this is what you call by continuity at a point means. At this time, we can consider the cat is as a function and the rat is at a number a. So its life is not defined, or it can be live like this. At that time, we say it is not defined or it cannot be alive. The rat cannot exist in such way, such a way, or the life cannot be continued like this. Why? Because rat, as you know, rat and the cat is by naturally their enemy. So such condition, when you bring to the mathematics, we can explain mathematically this is not defined, which means that impossible. Not defined in a sense, the values can be represented any number over 0, or 0 over 0, infinity over infinity, or infinity minus infinity, or 1 power of infinity and extra are called undefined. At that time, if the function is not defined, automatically. So for further explanation, this definition will be shown using the following different cases of examples, as we have changed different examples since we have different examples of a function. Let's say the first example. Identify whether the following functions are continuous at the given point. Let's say function f of x equals to x squared plus 1 over 2x minus 3 at a number a, which is equals to 1 over 2. So we'll be check these three conditions. If it's satisfied, we'll say continuous. If it violates one of the conditions, we'll say it is not continuous. So let's go. Directly we will evaluate the function at the number of a, which is equals to by what you call sometimes, which is functional value. That's why f of a, in a sense, we are going to be evaluate 1 over 2 at the place of x. So I have x squared, so we'll have 1 over 2 squared, again 1 over 2 times 1 over 2. I have substitute 1 over 2 instead of x, then minus 3, and combine this one. Organize, and you will have a final answer minus 5 over 2, which is defined, which means that this number is just exists, or this is an element of real number, or it is different from any number over 0, or 0 over 0, infinity over infinity, which is different from, or this is not element of the indeterminate. So the first criteria is satisfied, and again the second criteria, or the second condition. Since this function is polynomial, then the limit is directly, we are going to substitute 1 over 2. That's why the same is true. The value is minus 5 over 2. Therefore, the limit is again exists at that time, which is the left and right are the same. Then this function is continuous at a number or at a point 1 over 2. 1 over 2 can decide. Why? Because it satisfies the three conditions. So have a remark, or you can generalize like this. Every polynomial function is continuous at every point, which means that not only at 1 over 2, it is continuous at any real number. So you are going to be defined, so there is no challenge to check the 3 conditions if you know the type of the function. 1, if it is polynomial function, automatically it is continuous at every point or at any real number. Okay, continue. For this second example again, we have a second example here, g of x, which is equals to x squared minus 1 over x plus 1 at minus 1. So we are going to be check using these 3 conditions whether this function is continuous at minus 1 or not. First condition, we are going to be check the functional value, or we are going to evaluate them at minus 1. That's why we are going to be evaluate at minus 1, then the value gives 0 over 0, 0 over 0, which is, this is not element of real number. So we say which is not defined, hence it is not continuous at 8 equals to minus 1. No need of to check condition 1, condition 2, condition 2 and 3, condition 2 and condition 3. Why? Because it violates the first condition. So we can conclude now it is not continuous at 8 equals to minus 1 for g of x, which is equals to x squared minus 1 over x plus 1. Remark, every rational function is not continuous at the zeros of its denominator or the point which is not element of its, which means that the function g of x, is rational function, so the domain of the rational function is or real number except the zeros of the denominator, or that's why the domain of for g of x is or real number except minus 1, except minus 1. That's why it is not continuous at minus 1. Okay, third example, h of x equals to log of x plus 2 at 8 equals to minus 2. Is it continuous, this h of x? So we'll be checking the first condition. We are going to, as usual or like the above examples, we are going to evaluate. That's why I'm insert directly minus 2 instead of the value of x. So minus 2 plus 2 is 0. Then finally I will get log of 0, which is not defined. We cannot say to log of 0 instance. Hence, it is not continuous. Log of 0 is not defined. Therefore, we will conclude it is not continuous at 8 equals to minus 2, because the domain of logarithm function is positive real number. So the domain of h of x is, it should be greater than 0. That's why log of into x plus 2 greater than 2, I mean greater than 0, then x plus 2 greater than 0, then x should be greater than minus 2. Therefore, the domain is those all of numbers or the set of numbers greater than minus 2, but except minus 2. It does not include minus 2 itself. Why? Because it makes log of 0. We cannot say log of 0, which is rather it is not defined. Hence, it is not continuous. That's it. Which means that minus 2 cannot be included at the interval, which is excluded. Why? Because we have the open interval. Another example, Rx, which is the function of Rx, which is equals to sec x at 8 equals to pi over 2. So at the usual example, we are going to evaluate at the pi over 2. Sec x means 1 over cos x, then 1 over cos x instance 1 over pi over cos pi over 2 is known, which is 0, then 1 over 0, which is not defined, or it is not an element of real numbers. Hence, it is not continuous at pi over 2, because the domain of sec x is or real number except the odd multiples of pi over 2. That's why pi over 2 makes undefined for x. As consequence of this one, sec x is not continuous at pi over 2, not only at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. In general, n pi over 2